Alright, so we're going to have a go here at sketching y equals x squared plus 6x minus 5. So we're doing question B. Remember, when you're sorting out completing the square, it's 2 times x times whatever that other factor is. Now, it has to equal 6x. So what number are we going to need to multiply by? 3. Yeah, of course. So then we add 3 squared to complete the square. Remember, your square has got to be in the form a squared plus 2ab plus b squared. So we've got it in that form, so I've added the 3 squared. I've got a minus 5. I can't cheat and add 3 squared, though, to something and say it's equal, unless I subtract the 3 squared later on. So I do that. Now I've got a perfect square that I know is going to factorise, so y is going to equal, that's just going to be x plus 3, all squared. And I've got minus 5, minus another 9, minus 14. Alright, this is called the turning point form. If you have, and let's just do a little bit aside here, the turning point form, y equals a x minus h all squared plus k, I said k and wrote h, there we go, k, that has a turning point, hk. So for this one, I can read the turning point off straight away. It's going to be negative 3, because remember it's x minus h over there, so that'll be negative 3, negative 14. So it says to label a turning point, and I'm going to be able to do that. I cannot yet label the intercepts though, can I? So let's work out what those intercepts are going to be. For the y-intercept, we always let x equal 0. So the y-intercept is just going to be 0 plus 3 all squared minus 14, which of course is going to be negative 5. Remember, we could have just got that from the original equation anyway, because we can see up there x squared plus 6x minus 5, we know that if x equals 0 in that one, negative 5, or the c value is the y-intercept. For the x-intercepts, we take this form and we keep going by letting y equal 0, correct? So we have 0 equals x plus 3 all squared minus 14. Now you want to be really clever here and not add 14 to each side of the square root, because that will mess you up. What do we do instead? We use our favourite rule in maths, which is, oh, difference of 2 squares, make me happy. So x plus 3 plus root 14, x plus 3 minus root 14. So we're going to get x equals negative 3, take root 14, or negative 3 plus root 14. Now we've got all our intercepts, we can go ahead and sketch this pretty easily, can't we? So, don't get too carried away with the scale. It's important you label everything. If you're doing this in an exam, I'd be using a ruler. If you're just doing it in your workbook, just try and draw a neat line and that'll be fine. So the turning point, negative 3, negative 14. So I'm going to say that's about negative 3, negative 14 there. We knew it was a smiley face one because the a value was positive. And now, negative 3, take root 14. Just estimate roughly how big root 14 is. You could use your calculator to get a rough estimate if you want. But we know the square root of 9 is 3. Square root of 16 is 4. So root 14 must be somewhere, yeah, it's like close to 4, but not quite 4, isn't it? Yeah, so somewhere around there. So it's bigger than 3, less than 4. That'll do us. So if we go minus 3 minus another 3, that's going to be like minus 6. So here we've got the turning point, which we said was negative 3, negative 6. So it's going to go through something like that, through the turning point. If I add a number that's just a little bit bigger than 4, I'm going to be just past 0 there. So that is obviously negative 3 plus root 14. And this intercept here, negative 3 minus root 14. Always label your equation. So it was y equaled x squared plus 6x minus 5, wasn't it? And we've got to label that intercept negative 5. And we're done. Not too bad. It doesn't need to be perfectly to scale. You get the idea. If you want it to be smart, check it on your calculator. Make sure it looks roughly similar. Your calculator will probably show it being a little bit narrower and steeper because that's generally the way they work. But it's that easy.